Today I'm going to start this serial adder by using what we call Moore machine. Okay, last class we seen about the Mealy machine. No? So today we'll discuss about the Moore machine and whatever the Verilog code also we'll see. Okay, so that is Moore machine, serial adder by using Moore machine. Okay, so in the Mealy machine you have just to give response. My voice is clear, no? Audible? Yes or no? Waiting for your response. Yeah, my voice is audible, no? Yes. Thank you. Okay. So here today we'll see about 1 second. Yeah, we'll see about serial adder. Serial adder using Moore machine. Serial adder using Moore machine. Okay. So I'm parallelly covering the digital concepts. Parallelly, I'm explaining the Verilog code and Testbench also. Okay. So basically, like in the Mealy machine, we have only two states, no? So we already discussed. I think you attended the session. Okay. So we have how many states? Yeah, you have G and H. In Mealy machine, you have G and H. Okay, but in Moore machine, you have four states. What are those states? One is G naught. Okay, G naught and G1. Okay, G naught and G1. So this is for what when carries 0 and sum is what? Sum is 0 and 1. Okay. So that means from here I can say that G naught is nothing but carry is 0 and sum is 0. Okay. So that means carry in 0 and sum is 0. Okay. And next G1. G1 is nothing but carry is 0 and sum is 1. Okay, carry in is 0 and sum is 1. Okay, and next you have h naught and h1. H naught and h1. So h naught and h1 are nothing but these are for carry in is carry is 1 and sum is 0 and 1. Okay, sum is 0 and 1. Okay, so that means from here I can write h naught equal to what? Carry is 1 and sum is 0 and h1 is carry is 1 and sum is 1. Okay, these are so total you have G naught, G1, and H naught and H1. Okay, H naught and H1. Okay, so first I will draw the basic state diagram. Okay, and next we will go with the designing steps. Okay, so for drawing this, first what you need to do, you need to draw the truth table for full adder. Okay, basic 1-bit full adder circuit. Okay, so 1-bit full adder circuit. Okay, so how many inputs are there? So let us take three inputs, A, B, and C in, and you have sum and carry, sum and carry out. Okay, sum and carry out. So how many possible combinations? 8 possible combinations. 0, 0, 0, 0, 0, 1, and 0, 1, 0, 0, 1, 1, and next to 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Okay, these are the possible combinations. Okay, so next this is sum 0 carry 0, sum 1 carry 0, sum 1 carry 0, and this is sum 0 carry 1, sum 1 carry 0, sum 0 carry 1. Okay, and sum 0 carry 1 and sum 1 carry 1. Okay, so from this I need to draw the state diagram. Okay, so how to draw the state diagram? So if you see the state diagram, okay, so if you draw the state diagram, so here first, so Moore machine, Moore, so Moore, the output. outputs is a function of only present state, no? Only present state. So how the state diagram will look like? So this is a state. This is the state, whatever the state by output, and here this is one more state by output, and so from here to here, if it is same state means here you need to indicate input. Okay, when it is come to this state, this is the input. Okay, like this we need to represent. Okay, so let us take first state. First state is what G naught. Okay, G naught by S. Okay, G naught by S. This is reset state. This is reset state. Okay, so if you see the G naught state, so that means here you have like this is so we already seen what is a G naught. G naught is nothing but carry 0 and sum 0, and G1. G1 equal to what? Carry 0, sum 1. Okay, and next you have H naught. H naught is carry 1 and sum 0, and H1 is carry 1 and sum 1. Okay, so let us take, this is nothing but carry input. Carry input is let us take G naught. Okay, this is carry in is 0 and sum 0, so this is G naught. Okay, and next so G naught, and next uh, so next you have so this is what this is also G naught. Okay, this is also G naught. Okay, and next so next you have, so carry in is 1 and sum is 1. So means you can consider this is H naught, H naught, and this is what carry is 0 and sum is 1. Okay, this is G1. Okay, and next if you see this one, so carry in is 0, sum is 1. So that means C0 S1. Okay, so that means this is G1. Okay, and this is also G1. Okay, and next coming to this one, so if you consider this one, this is 1 and 0. So carry is 1 and sum is 0 means what? This is H naught. Okay, and here this is also H naught. And so this is the my present state. This is my next state, and this is my output, and these are the inputs. These are the inputs. Okay, and coming to this one, so carry 0 and sum 1. So carry 0 sum 1 is, this is G1, and this is also G1, and 1 0. So this is H naught, and this is H naught. Okay, and next 0 0 means this is G naught, and 1 0 means what? 1 0 means so carry 1 and sum is 0. So this is H naught, and 1 1 means this is H1. Okay,
Sir,
this is H1. Yeah, tell me.
sir, in second case, sum is 1 and carries 1, so H1 is there, right?
Yeah, yeah, sorry. So this is what H1, no? Okay. Yeah, thank you. This is H1 and this is G1. Okay. And this is also sum and carry out. This is H1. Okay. This is H1. Okay. I think it's fine, no? Yeah. Okay.
Yes, sir.
Yeah, yeah. So here I need to draw the state diagram. So state diagram. So suppose if it is G0, so when you are in G0, okay. So if you are in G0, so when the input is 0 0, so what is the next state? It will be in the same state only. Okay, it will be in the same state only. Okay, and next this is what this is G1 by S. Yes, this is equal to 1. This is sum S equal to 0. Okay, and next you have one more. This is H0 by S. S equal to 0. Okay, S equal to 0, and this is H1 by S equal to 1. S equal to 1. Okay, so you need to check each and every case. Okay, G0 by S. So you are at G0. So you are at G0. Suppose if it is input is 0 1. Okay, if it is input is 0 1. Basically, input is 0 1. What is the next state? So if you need to check for for G0, you need to check for all the cases. What are those cases? 00, 01, 10, and 11. Okay, all these cases you need to check. Okay, so you are at G0. Okay, you are at G0. That is the present state. Suppose input is 01. Okay, input is 01 means. So what is the next state here? If input is 01, so basically so this is it is going to G1, is going to G1. Okay, so this is 0 1. Okay, if it is 1 0 also, you need to see this one. Okay, so this is 1 0. Okay, if it is 1 0, it is going to G1. Okay, and next if it is 1 1, where it is going, if it is 1 1, it is going to H naught. G0 H naught. Okay, so this is H naught. Okay, so this is 1 1. Okay, all cases I see. Okay, and next similarly you need to check for G1 also. Okay, so G1 if you see, so G1 you are at G1 when input is 0 0. Okay, when input is 0 0, it should go to which state means you are at G1, no? 0 0. Input is 0 and okay. Input is 0 means it is going to, let us take the present state is G1 means so what is the next state? Input is 0 0. It is going to G1. Okay. It is going to G1 0 0. Okay. And next if the input is so 0 1, it will be in the same state only. It will be in the same state. 0 1, it will be in the same state. 1 0 also, 1 0 also, it will be in the same state. Okay, 1 1 if you see, so 1 1, it is going to which state means it is going to H naught. This one, it is going to H naught. Okay, from G1 to H naught it is going. Okay, this input you need to consider as 1 1. Okay, so for G1 all cases are completed, and next for H naught you need to see. Okay, H naught if it is 0 0, it is coming to what? So this is H1. Okay, so if it is 0 0, it is coming to what is the next state? G1. It is coming to G1. Okay, if it is 0 0. Okay, and if it is 0 1. Okay, if it is 0 1, it is staying in same state. Okay, it is same in the same state. Okay, 0 1, and next 1 0 also. Okay, 1 0 also, it is saying in the, it is staying in the same state. 1 0. Okay, and next if it is 1 1, it is coming to the next state H1. Okay, it is coming to the next state 1 1. Okay, so for H naught also I see in all the cases. Okay, H naught. Okay, and similarly you need to see for H1 also. If it is 0 0, okay, if it is 0 0, it should come to where G1. Okay, next state is G1. Okay, next state is G1 if it is 0 0. Okay, and if it is 0 1 and 1 0. Okay, if it is 0 1, it is coming to which one means H naught. H naught. Okay, it is coming to H naught. Okay, and 0 1, and if it is 1 0 also, it is coming to H naught. Okay, and if it is 1 1, it will be in the same state only. It will be in the same state only. Okay, so like this you need to draw the state diagram. Okay, like this you need to draw the state diagram. Okay, so we draw the state diagram. After that, you need to design the circuit. Okay, you need to design the circuit. Okay, process is same only. Okay, process will be same only. So first you need to draw by seeing the state diagram. You need to draw the state table. Okay, so this I am taking this state diagram. You need to draw the state table. So how to draw the state table? State table. So state table. So you have present state, and next you have next state, and in the next state you have AB, AB, and AB, and AB. Okay, these are nothing but 0 0 0 1 1 0 1 1. Okay, and only output is there. Okay, output. Okay, so by seeing the state diagram, you need to draw the state table. Okay, so you are at a G naught. You are at G naught. If input is 0 0, it will be in the same state only. G 0. Okay, it is same state only. If input is 0 1 and 1 0, it is going to be state G1. Okay, and if input is 1 1, it is going to H naught. H naught. What is the output? Output, this G naught by S equal to what? 0, no? So output is 0 only. Okay. And next, you for G1 you need to see. So G1, if input is 0 0, where it is going, next state is H naught, no? Okay. G1 input is 0 0. Okay. Tell me G naught. G naught. It is going to G naught. Okay. And 0 1 and 1 0, it will be in the same state only. So this is G1 and G1. And if it is 1 1, it is going to H naught. Okay. What is the output? Sum equal to 1. Output is 1. Okay. And next H naught. H naught. H naught means you are at, so that means if input is 0 0, where it is going to G1. G1. And 0 1 and 1 0, it is going to H1. H1. Okay, and if it is 1 1, it is going to G1. G1. Okay, if it is 1 1, one second, you are at H naught, no? If it is 1 1, it is going to H1. It is going to H1. Okay, H1, and if it is 0 1 and 1
Sir,
0, it's same state.
zero.
Is it fine? Yes.
Yes, sir.
Okay, H1, and the output is 0, and H1. Okay, H1. You are at H1. 0 1 and if it is 0 0, what is the next state? G1, and next 0 1 1 1 0, H naught and H1, and next 1 1, it is H naught. This is H naught. 0 1 and 1 0, H naught, and 1 1, it will be in the same state. Output is 1. Okay, is it fine now? Yes. So you need
Yes,
to
sir.
draw the state, means you need to assign the states. Okay. So what are the states you need to assign? G naught equal to, let us take 0 0. Okay. H naught G1 equal to, you need to assign 0 1. H naught equal to 1 0. H1 equal to 1 1. You need to assign the states. Okay. After assigning the states, you need to draw the state assignment table. State assignment table. Okay, state assignment table. So if you see the state assignment table, so here present state, next state, okay, and what are the inputs? So inputs are here you have A B, and A B. So possible input 0 0 0 1 1 0 1 1. Okay, and let us take this is Y2 Y1, y2 y1, y2 y1, and y2 y1. Okay, and output. Okay, here this is output and present state. Okay, present state. Okay, so here if you see, so based on the state assignments, I need to write the values. So this is 0 0 0 1 1 0 1 1. Okay, so G0 means what? 0 0. G1 means 0 1. G1 means 0 1, and H naught means 1 0. Okay, and next G0 means what? 0 0 0 1 0 1, and 1 0. Okay, and next G1 means what? 0 1. H naught means 1 0, and this is 1 0. H1 means 1 1. Okay, and next G1 means what? G1 means 0 1. H naught means 1 0. This is 1 0. H1 means 1 1. Okay, and what are the outputs? 0 1 0 1. Okay, by using the state assignment table, you need to draw the detailed state assignment table. Okay, so you need to draw the detailed state assignment table by seeing this expanded state assignment table. Okay, expanded state assignment table. I need to draw. Okay, so what is the expanded state assignment table? Expanded state assignment table. Okay, So expanded state assignment table if you take, so here you will get what are the present state and inputs, present state and inputs. Okay, these are y2. Okay, yeah, these are nothing but what? These are nothing but y2, y1, y1, y2, y1, and e. These are the inputs. Okay, and what are the outputs? So what are the next state values? One second. Mm, inputs are a comma b. Okay, inputs are nothing but a comma b. Okay, so present state and inputs a comma b, and outputs next state. Next state are nothing but let us take y2 plus and y1 plus. These are the next state values, and sum. Okay, so this is output. Output is sum. Okay, so four inputs are there. How many possible combinations? You will have 16 possible combinations. Okay, 2 power 4. 2 power 4 means 16 possible combinations you have. Okay, so you have 16 possible combinations you need to draw. Okay, so I am drawing this. Okay, so 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 1. Just I am dividing for readability. 0, 1, 0, 0, 0, 1, 0, 1, and 0, 1, 1, 0. Okay, 0, triple 1. Okay, and next you have 1, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. Okay, and next this. So here if you see, this is 11, no? So 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. Okay. So by seeing the state diagram, you need to draw the state assignment table. Okay. So here if you see the detailed state assignment table, yeah, yeah, see here. So detailed state assignment table, yeah. So when it is present state is input, present state is what? Present state is 0, 0, and input is 0, 0. What is the next state? Next state is what? 0, 0. Present state is 0, 0. Next present input is 0, 0. What is the next state? 0, 0. Okay. And next present state is 0, 0. Next state is 0, 1. What is the next state? 0, 1. Okay. And present state is 0, 0. Next state is present input is 1, 0. What is the next state? 0, 1. Okay. Present state is 0, 0. And present input is 1, 1. What is the next state? 1, 0. Okay. What is the output you are getting? In this case, you are getting all zeros only. Okay. By seeing this table, I am drawing the detailed state assignment table or expanded state assignment table. Okay. And next, present state is 0, 1. Input is 0, 0. What is the next state? 0, 0. Okay. And present state is 0, 1. Input is 0, 1. What is the next state? So just you need to draw this. You need to write this. Okay. So this is the 0, 1, 0, 1, and 1, 0. Okay. What is the output? 1. All ones. Okay. And next, this row you need to write. Okay. What are the next state values? Hope you understood how I am writing. Okay. 0, 1, 1, 0, 1, 0, and 1, 1. Okay. What is the output? 0, 0, 0, 0. Okay. And next, coming to this one. So here, if you see, so this is 0, 1, 1, 0, 1, 0, and 1, 1. What is the output? 1, 1, 1, 1. Okay. So next, what you need to do? You need to get the min terms for y2 plus y1 plus and s. Okay. So y2 plus y2 plus with respect to inputs. What are the inputs? Inputs are what we call so input y2 with the inputs y2, y1, a. Okay, equal to summation of m of what are the min terms? Tell me the min terms. By seeing this, tell me the min terms. Tell me the minterms. 3, 7, y2 plus 3, 7. Wherever the ones are there, 3, 7, and next this is 9, 10, 11, 13, 14, 15. Okay, and next y1 plus with the in terms of inputs y2, y1 comma a comma b. Okay, this is a 4 variable, no, a comma b. Okay, equal to summation of m of yeah, wherever the ones are there, tell me 1 to 1 to 5, 7, 5 6, 1 to 5 6, 8, 8, 11, 12, next 4, 15. Okay, and sum equal to what? S equal to S in terms of y2, y1, a comma b. Okay, by saying this, I need to write them in terms. Okay, uh, so 4, 4, 5, 6, 7, next 12, 13, 14, and 15. Okay. This you need to draw the K map and you need to get the expressions. Okay, that is your task. Just you draw the K map and you need to get the logic expression. So here I am writing the expression. Okay, so just you cross check whether you are getting this or not. So y2 plus equal to you are getting ab plus ay2 plus by2. Okay, and next y1 plus equal to you are getting a xr b xr b xr. This is 1 second. Y2 you will get a xr b xr. Yeah, y2 you will get a xr b xr y2. Okay, a xr b xr y2 and sum equal to y1 you will get. Okay, so based on my expression, these expressions, I can design the circuit. Okay, I can design the circuit. Okay, how to design the circuit? So here you see. So I can design the circuit. Yeah, see here. First, this is my full adder. Okay, full adder circuit. Full adder, full adder circuit, and inputs are A and B. Inputs are A and B, and output is sum. Okay, sum bit. This is my output. Okay, and next, so this one is y1 plus next state. Okay, y1 plus, and basically you have two D flip flops will be there. Two D flops will be there. Two D flip flops. Okay, and here this D is given and Q is given. Okay, and so what is sum equal to what you are getting y1. Okay, initially you got no. So what is sum? Yeah, see here. S equal to what? Y1. Okay. S equal to Y1. Okay. And next, common clock is given to these two flip flops. Common clock is given to these two flip flops. Okay. This is clock. This is my clock. And I'm using asynchronous active low reset. Asynchronous active low reset. Okay. Common reset will be given. Synchronous active low reset. Okay, and next carry out is there, no? So carry underscore out. Okay, carry underscore out. This is given to this D flip flop. Okay, this is D flip flop. So this is let us take y2 plus. Okay, y2 plus and q. This is y2, and this is given as a feedback to the this full adder circuit. Okay, so from here I can say that we'll get so s equal to what y1 and next y1 plus equal to what same as the full adder circuit. That means a xr b xr. What is one more input? One more input is y2. Okay, one more input is y2 and next y2 plus y2 plus equal to what carry out, no? So carry out equal to what ab plus, so you did know, you got y2 plus equal to ab plus ay2 plus by2. Okay, so ab plus ay2 plus by2. Okay, so like this you need to design the serial adder. Okay, is it the fine now? Any doubts or any queries? Shall I go with programming part? Yes.
Yes, sir.
Okay. So I'll go with programming part. So one second. I'm opening my Xilinx Vivado. Yeah, serial adder I got the program. Right here if you see the Xilinx Vivado. Yeah, serial adder using Moore. Okay. Just I'm copying this and I'm pasting in GVim. Okay. And this one I'm saving the file with what means uh, serial adder Moore. Okay, so just to copy this, save this in where means here I created the folder RTL codes serial adder. Serial adder I created two files. Okay, RTL sim and here you made this file. You create the file. Okay, .v file. Okay, in RTL folder. Okay, save this file. Okay, and next TB also. Okay, so create one GVim. Okay, and next here TB file is there. No, so TB more. Okay, this is TB more. Just copy this and paste it here. Okay, and what is my TB file name? TB underscore serial underscore more. Okay, so this copy this, uh, save this file. Okay, I need to go to TB. Okay, TB and file name dot v. Okay, save this. Okay, so just so it will be like means if I show in the dining window, you can't see. That's why I can expand this. Okay, it will be easy for you. So here you see, just I'm expanding this. First, I need to include the inputs. So what are the inputs? Module serial, and so this is module, and this is my identifier module name, and input wire clock, input wire resetter, input wire starter, and input wire A and B. Two inputs are there, no? And input output I need to initialize as reg. Okay, reg sum and reg done. Why? Because I'm using behavioral modeling. So in the portal connections, you already seen like we need to initialize with reg data type. Okay, and starting encoding, I need to use the parameter. So parameter idle state is 0, 0, add state is 0, 1, and done state is 1, 0. Okay, I'm initializing reg 1 down to 0. So this is two state, no? So I'm initializing a vector 1 down to 0, current state and next state. Okay, reg carry comma next state, and reg 2 down to 0 bit count. This is 3 bit. Bit count is 3 bit. Okay, so basically my next state logic is a combination logic, and present state logic is a sequential circuit. Okay, sequential logic. Basically, in the FSM, next state logic is a combination logic, and present state logic is a sequential logic. Okay, so here what I am doing is here next state logic and output logic I am writing. Okay, always at the rate star. Star means what? So this is the implication operator. So this will be applicable to all the inputs. If there any change in the inputs, that will be applicable. Okay, basically like 100 inputs or 150 inputs are there. So we use this implication operator on this. Okay, next state equal to current state. Okay, done equal to 0. Next carry equal to carry. I am using case statement. Okay, case current state begin, idle begin, if starter. So that means next state equal to what? Add, end. Okay, so it will go into the add, next state equal to add. So perform the single bit addition. So by using concatenation operation along with the carry and sum, I am doing the single bit addition, a plus b plus carry. This is the serial adder, no? Okay. If bit count equal to 3, next state is done. If bit count, else, you need to do the add. Okay, this is nothing but add operation. And done means what? Begin done equal to 1, next state equal to, it will come to the ideal state. Okay, so this is nothing but a basic add operation I am doing. Okay, and sequential logic, if you take, always at the rate passage of clock or negate of reset, begin. Okay, begin. I am using asynchronous active low reset, if not of reset. Okay, begin, if not of reset, begin, current state equal to what? Ideal state, carry equal to 0, sum equal to 0. Okay, in the ideal state, current state, ideal state, carry equal to 0 and sum equal to 0. Okay, and bit count also you need to initialize to 0 and done equal to 0. Okay, so these are the reset values. Okay, when you are making the reset, so you need to reset to the current values and else. Okay, here you need to get the functionality. So current state equal to next state, carry, next carry. Okay, so if current state equal to add, so bit count is incremented by 1. Okay, else if current state equal to idle state or bit count equal to 0. Okay, and end model. Okay, so just you are like you are adding the serially, you are adding. Okay, so this is the Verilog code. Okay, for the serial adder. And coming to the test bench. Okay, this is the test bench. Just, increase the font size. So this is module, and my module name is PB underscore serial adder underscore more. And whatever the input variables are there, that I need to initialize with reg data type, reg clock, reset start, reg 3 down to 0 a comma b, reg a underscore bit and b underscore bit. While so output variables I need to initialize with wire. Okay, wire sum comma done and integer I. So I need to instantiate the design. Okay, how I'm instantiating your design under test. That is your design name. What is my design name? Serial underscore under underscore more. Design under test. I'm using which type of design instantiation means connection by name. Okay. So connection by name is what? Whatever the variables outside the bracket are nothing but design inputs and outputs, and whatever the variables inside the bracket are nothing but a test bench inputs and outputs. Okay, and next I need to generate the clock. Always the hash by clock equal to not output. You need to generate the clock. Okay, so the difference between the combinational and sequential is this only. So the combinational clock will be not there, but in sequential you need to generate the clock. The clock period is 10 times. Okay, nanoseconds. That will be nanoseconds, 10 nanoseconds. Okay, so when you are using EDA playground, you need to use this dump file serial adder underscore more dot bcd 0 comma tb serial adder more. Okay, if we are using Xilinx video, this one is not required. Okay, first you need to make reg variables to 0. That means clock equal to 0. This is active to reset. No, reset you are making as 0, start equal to 0, a underscore bit equal to 0, and b underscore bit equal to 0. And next, I'm initializing values. A equal to 1011 means 11. B equal to 0110 is nothing but 6. Okay. So that means basically this is in reset mode. Okay. I'm making reset equal to 0 means what? Reset mode. Okay. After that, I'm making this reset equal to 1. That means I'm making this into functional mode, and I'm making start equal to 1. And I'm applying the bit serially. Okay. LSB to MSB. Okay. Serially it should add, no? So for that I am using for no, for I equal to initially I initialize this integer I know. So that I am using in the for loop. Okay, for I equal to 0, I less than 4, I equal to I plus 1. So a underscore bit equal to a of I, b underscore bit equal to b of I, and I need to I need to give the stimulus. Okay, I need to give the test vectors. Okay, so the test vectors to the design. Design will do all those addition operations. Okay. So for every combination it will add and it will give the output. Okay. And after that making start equal to 0, I need to see the simulation for 50 time units and display the simulation complete, and dollar finish is nothing but you need to finish the simulation end and end module. Okay. So this is my test bench for serial adder using Moore FSM. Okay. Moore FSM. Okay. Yeah, Moore FSM. Okay. So here, this one I'm executing in Xilinx VBAD. Okay, so same program I wrote. Okay, suppose if you want to see the design, just right click in the design sources, set as top. Okay, right click in the design sources and set as top. Okay, and Next, TB or Moore is there. This is also top model is there. We can elaborate the design. We can elaborate the design. So reading the net list. Yeah, this is my design of serial adder. Okay. So this is my different designs. How the tool is converted your Verilog code into different net list or designs. Okay. So this is my design. I want to do the simulation. Okay. Run behavioral simulation. Okay. You can see the output in the console also. TCL console also. You can see the outputs. Where we can think TCL console. You are not getting the output. Okay. Yeah. So I can see in the simulation part. See here. So expand this bit to page. Initially, when the reset equal to 0, the output will be 0 only. Okay, all the outputs are initialized to 0. Okay, these are A and B are nothing but inputs. Okay, A I am giving as what 1 0 1 1, no? That is B. Okay, and next B I am giving as what 6 6 is nothing but 0 double 1 0. Okay, so when reset equal to 0, all the outputs will be in reset state only. So when it is going from reset mode to functional mode, you are not getting outputs immediately. So you are getting the outputs during the passage of clock. Why? Because in the code we already given always at the rate passage of clock or decade of reset. Okay. So that means when it is going to the functional mode, this is synchronous with the clock. Okay. Synchronous with the clock. Okay. And here you see. So that means here, anyway, 0 0 means what? So first bit is nothing but during the first clock pulse, first bit will go. So 0 0 means 0 only. You are getting sum equal to 0 only. Okay. And during the next clock pulse, you see here you see. Okay. Here you see this is so here what is my output? So here A bit yeah. A bit is what? A bit is 1 and B bit is 0. Okay, A bit is 1, B bit is 0. Okay, serially it is adding. Okay, so 1 0 means what? You are getting sum equal to what? 1. You are getting sum equal to 1. Okay, and next you see 1 1 bit it will transmit it. Okay, and that will be added and that will be stored in the shift register. Okay, see here during this case 1 1. 1 1 means what? 1 1 means you are getting sum only. Okay, sum equal to 1. Okay, during this passage of clock, during this passage of clock, 0 1, you are getting 1 only. Okay, you are getting 1 only. And during this passage of clock, so here, what is this? This is the EBIT is 1. One second. EBIT is 1 and BBT is 0, no? Okay. So till here you got the output. That means output you are getting as 1. Serial it is adding the bits. Okay. So adding the bits and so here that means till the start equal to 1 it will do the operation. Okay. And the start becomes 0, the output becomes what? Uh, 0 only. Okay. Till here this is so done is so here you see here till here so start is 1 only. Okay, start is 1 means it is doing the addition operation. Okay, so like this we can see the simulation in the serial adder. Okay, we hope you understood.